Now that we have learned on how to use inverse method to solve simultaneous equations of two unknowns, now let us apply it to three unknowns. It's still the same process. However, this one is quite lengthier. Alright, so let's reduce what we have here. Remember, in our previous video, we learned that if you have A11, A12, A21, A22 multiplied by a set of unknowns, x1, x2, and it's going to give us a b1, b2, we know that x is equals to A inverse multiplied by b, where this is equals to A, this is x, and this is b. Now that is for a 2 unknown, that's a 2 by 2 matrix. Now if we apply the same thing for a 3 unknown, so we have A11, A12, A13, A21, A22, and A23, and A31, A32, and A33, and this in itself will be multiplied by 3 unknowns, x1, x2, x3, which is equals to b1, b2, and b3. Now the result of x is still going to be the same as A inverse multiplied by b. So once we now know that whether it is 2 unknowns, 2 equations, or 3 unknowns, 3 equations, it can also be 4 unknowns, 4 equations, or even 6 unknowns, 6 equations. All we just have to do is to evaluate the inverse multiplied by the constant of b. We are given this set of questions: 3 unknowns, 3 equations. So of course, what we first thing need to do is to evaluate the set of coefficients. So this is 2 minus 1, 3, 1, 3, and minus 1, and likewise 2 minus 2, and what, 5. The set of unknowns x is let's call it x1, x2, and x3, and the constant b is what, 2, 11, and 3. Now the first thing we need to know is, oh yes, we are applying this formula, correct. The first thing we need to know is the inverse of A. The inverse of A. But then before we calculate the inverse, we have to know that, oh yes, let us check, is the determinant not equals to 0? Because if the determinant is equals to 0, we will not be able to evaluate the inverse, and once there is no inverse, there is no solution. So the first things first, let's evaluate the determinant. The determinant of A can be determined using the first row, like we have always done, and we apply our place signs of positive, negative, and positive. So that will be plus 2, and we'll be left with this 3 minus 1 minus 2 and 5. If you have any issues with this, please refer to the videos on determinants of matrix, of 3 by 3 matrix. And we have minus into minus 1, okay, and we'll be left with 1 minus 1, 2, and 5, and plus 3, 1, 3, 2, and minus 2. So this is plus 2 into 15 minus 2 plus 1, resulting into plus 1, into 5 minus into minus 2 plus 3 into minus 2 minus 5. With all this done, our determinant of A is equals to 9. So yes, the determinant is not equals to 0. Definitely, we can go ahead and evaluate our matrix, our inverse of matrix. So remember now, this is a 3 by 3 matrix, okay? For if it is a 2 by 2 matrix now, let's say A is equals to AB CD, that's a 2 by 2 matrix. The inverse is simply 1 over the determinant of A for the matrix of DA minus C and minus B. However, this is not a 2 by 2 matrix, it's a 3 by 3 matrix, and for a 3 by 3 matrix, the inverse of the matrix is equals to 1 over the determinant multiplied by the adjoint of the matrix. Yes, I can hear you screaming that. Oh, so now to evaluate adjoint of A, and we know that adjoint of A is the transpose of the cofactor. So yes, we are going to evaluate the cofactor of each term to go on and on down to this, and that's quite a lot. Okay, so I would have skipped it, but for more understanding we will do it together. So let's begin. So if we rewrite our expression of A here now, let's copy what we have here. Let's write our expression of A, and we want to evaluate the cofactor of this. We know the cofactor is represented by C, so it will be A11, A12, A13, A21, A22, and A23, A31, A32, and A33. So let's complete our place signs. So the place sign here will be negative, positive, negative, and positive, negative, positive. So let's evaluate the cofactors now. So A11 now, I'll skip a lot of steps because of time. A11 will be equals to plus, all right, and 3 minus 1 minus 2, 5. And when we do this, we will arrive at 13. A12, place sign negative, and when we cover this horizontally, vertically, we are left with 1 minus 1, 2, and 5, and the determinant of this alongside the place sign is minus 1. A13, positive of this 1, 3, 2, and minus 2, and the result is minus 8. A21 now, A21 is, we are considering this, which has a negative place sign. Horizontally, vertically, we are left with 1 minus 1, 3, 2, minus 2, and 5, minus 1, 3, minus 2, and 5, and this is equals to minus 7. And let's look at A22 now, considering this positive plus sign, and 2, 3, 2, and 5, 2, 3, 2, and 5. With this done, we have an answer of 4. Okay, I think I made a mistake, sorry. This is 13 correct, minus 1 because I'm trying to skip step. This should be minus 7, minus 8 is correct, and this is minus 1 times 5, minus 5, minus minus 6, and that is minus 1, and this will be equal to 4. Yes, now let's proceed. Now A23 is equal to the place sign for this negative, and once we do that horizontally or vertically, we're left with 2 minus 1, 2 minus 2, 2 minus 1, and 2 minus 2. So this will result into minus 4 minus minus 2, that's minus 6. No, that's 2. Yeah, 2. And A31 now is equal to plus, that's the place sign of that, and we have vertically and horizontally, so we will be left with minus 1, 3, and 3, and minus 1. We perform the operation here, will result into minus 8. And moving on, A32, that's the place sign on minus 2, which is what? Negative. And we have this horizontally, vertically, 2 3 1 minus 1. So we have 2 3 1 minus 1, and this would result into 2 times minus 1. We have minus 2 minus 3 minus 5 multiplied by minus negative, that's plus 5. And 833 now, okay, that's the place sign here is positive, and we have to evaluate 2 minus 1 1 3. So 2 minus 1 1 and 3. So this will result into 6 minus minus 1, that's 7, positive, which is equal to 7. Now we have evaluated a11, a12, that's the cofactor. So we know that the cofactor will be related to 13, that's a11, a12 is minus 7, a13 is minus 8, a21 minus 1, a22 4, a23 is 2, a31 is minus 8, a32 is 5, a33 is 7. Now we have evaluated the cofactors. Now let's remember ourselves of the rule on matrix inverse of a 3 by 3. The matrix inverse of a 3 by 3 is 1 over the determinant of A multiplied by the adjoint of A, and we know that the adjoint of A is equals to the transpose of the cofactors. Now let's evaluate the adjoint of A, which is the transpose of the cofactor. You know, this is A. Now let's proceed. Now if we transpose this guy, now we will have 13. If row becomes the column, 13 minus 1 minus 8, minus 7 4 and 5, minus 8 2 and 7. Now let's now apply what we have here. We know now that A inverse will be 1 over the determinant. The determinant of A that we evaluated is equal to 9, and the adjoint is 13 minus 1 minus 8, 7 4 5, minus 8 2 7. So now that we have evaluated the inverse, let's go back to the formula where we said x is equals to A inverse multiplied by B. So we have evaluated A inverse, and what's next is to multiply it by B. So let's go back and see, okay, what is B? B is 2 11 3, 2 11 and 3. So let's multiply them together now. That means we're saying x, a set of constant of unknowns of x1 x2 and x3, is equals to A inverse 1 over 9, 13 minus 1 minus 8, 7 4 and 5, minus 8 2 and 7, multiplied by B, which is 2 11 and 3. Now I'm going to skip the multiplication of this, else the video is going to be exceedingly long. We know that this is a 3 by 3 matrix, and we know this is a 3 by 1 matrix. So when we multiply it, we are going to result into a 3 by 1 matrix. Alright, let's solve it together then. So 1 over 9, that's the scalar multiplier, and we know we have a matrix of first row multiplied by the column, 13 multiplied by 2 plus minus 1 multiplied by 11 plus minus 8 multiplied by 3, and the next row would be 7 4 5. Okay, 7 multiplied by 2 plus 4 multiplied by 11, and we have 5 multiplied by 3. And finally for the third row, minus 8 multiplied by 2 plus 2 multiplied by 11 plus 7 multiplied by 3. So when we perform all this, we have 1 over 9 into minus 9, 45 and 27. So this is x, and we know that x is a set of unknowns of x1, x2, and x3. This is a scalar multiplier. So when the scalar multiplier applies to all, we know that we will have -1, 5, and 3. So we can come to a conclusion that x1, x2, and x3 is equal to -1, 5, and 3. So for this question now, we can now conclude that x1 is equals to -1, x2 is equals to 5, x3 is equals to 3. So concluding on inverse method of solving matrix functions, we know that x is equals to A inverse multiplied by B. Now let's take a look at how to use determinant method or Palmer's rule to solve simultaneous equations. We'll start with 2 by 2, 2 unknowns, that's 2 simultaneous equations, and then we'll move on to 3 unknowns, 3 simultaneous equations.